Hello everybody, this video is going to cover our 6.6 notes, which is area and perimeter for similar figures. So before I get started, I do want to remind you that we started talking about similar figures back in Unit 4. And when we talk about figures that are similar, we're always going to end up having to set up proportions, okay, based on ratios. So when we are told that we have two shapes that are similar, we have to figure out what ratios we need to use in order to set up our proportions. And these ratios are dependent upon a couple of different factors. So in this first example here, I have two rectangles, and what we're going to do is I'm telling you right now that the figures are similar. So you've got your small rectangle and your large rectangle. They are similar, and what I need us to do is find the perimeter of both rectangles and then the area of both rectangles. So remember that perimeter, we just add all the sides together. So this is a 3 and this is a 2, 6, 7, 8, 9, 10. So this would be 10 meters for area, and then, 10 meters for perimeter and 6 meters squared for area. And then the perimeter of the larger shape, that's 6, 7, 8, 9, 10. So this would be 20 meters. And then area would be 24 meters squared. So what I want us to do first is we need to figure out what the ratio of sides are. So we can look at this in two ways. We can either look at the two right sides of our rectangle or the two bottom sides of our rectangle. Either way we do this, anything over here is going to go on top and anything over here is going to go on bottom of our ratios. So I have 2/4, which would be the right side, or we could also say that we have 3/6 if we were looking at the bottom parts of our rectangles. Whenever we are looking at ratios, we want to simplify these. So my ratio is going to be 1/2 or again 1/2, and they should be the same. So whenever we are looking at this example of similar figures, the ratio of sides is a 1:2 ratio. Okay, so essentially one rectangle is twice as large as the other in terms of its sides. Now what I want us to do, though, is look at the ratio of the perimeters. Remember that we found the perimeters here. So again, anything on the left is going on top. So 10 is going to go on top, and then 20 is going to go on bottom. When I simplify 10/20, I again actually get 1/2. So the ratio of sides and the ratio of the perimeters of similar figures should actually be the same. Okay? Now what we need to do is we need to look at the ratio of our areas. So here we've got a 6 and a 24. So I'm going to put 6/24. And when I simplify that, that's actually going to get me a 1/4, which is not the same as the other ratios that I have found for these two similar figures. And so normally what I would do is if you were in class, I would ask you, how are the ratios of sides/perimeters when I compare them to the ratio of the areas? And a lot of kids have a hard time seeing it, but essentially what's happening is the ratio of your area is the same ratio as your sides and perimeters squared. So 1/2 squared is 1/4, okay? So just so that we can see this quickly and easily, the ratio of sides and perimeters will always be the same, and the ratio of areas will always be the ratio of the side/perimeters squared. So I'm going to skip the square and I'm going to actually move down to the triangle, and we're going to do the same thing that we did. First thing that we're going to do is find the perimeter, 18, 19, 20, 21, 22, 23, 24. So this has a perimeter of 24 meters or whatever the units are. I don't actually know the units for this one. And then this will give me 9, 10, 11, 12. And then the areas, remember for a triangle, area is base times height divided by 2. So 6 times 8 is 48 divided by 2, which is 24. And then the area here would be 4 times 3, which is 12. 12 divided by 2 is 6. So first thing I would like for us to do is look at the sides and come up with the ratio for the sides. So if I look at the left, or the height of my triangles, that would be an 8/4, which simplifies to 2/1. If I look at the hypotenuses of both of these, we have 10/5, which also simplifies to 2/1. And then we have the bottom or the base, which would be 6 over 3, which also simplifies to 2 over 1. So the ratio of sides right now would be 2 over 1. And as we know, the perimeter should be the same as the side ratio. So we have 24 over 12, which does simplify to 2 over 1. So we know that we have the sides and the perimeter ratio the same. So now what I need to do is I need to look at the ratio of my areas, which is 24 over 6. So when I simplify 24 over 6, I get, let's see, 24 divided by 6 is 4 over 1. So again, it is your the ratio of sides and the ratio of your perimeter squared. Okay. So part A says, what relationship exists between the ratio of sides and the ratio of perimeters? They're the same. We've already seen that. And then what relationship exists between the ratio of sides and the ratio of areas? So your area is your sides squared. Okay, so what we do is we have to set up something called a SPA chart. So anytime that we have similar figures, I want you to set up what we call a SPA chart. And what we're doing in this SPA chart is we are putting our side length and our perimeter ratios together because they're the same. And then you have your area ratio over here by itself. So even though up here we had 3 columns, remember that these first 2 columns are always the same. And then the second column, or I'm sorry, the third column is always different. So instead of making 3 columns, we just make 2. If you want to make 3, you can. But essentially what we're going to do is we are going to look at what we're given. Are we given our sides? Are we given the perimeters? Or are we given the areas of these similar figures? And we're going to put them in our SPA chart. And then what we're going to do is we are going to finish filling out the SPA chart based on the information that we're given. So for this first example, it told me that I have 2 similar quadrilaterals, and I need to find the ratio of sides, the ratio of perimeters, and the ratio of areas. If you look at this image here, hopefully you see that you were actually given the side lengths. So because of that, my side ratio will be a 7:3. The perimeter would also have a ratio of 7:3, which is why it's still in the S&P column. And then to get your area ratio, you just square the numerator and the denominator. This would be 49 over 9. Okay. So it says, what is the ratio of sides? That's a 7/3. What is the ratio of perimeters? It should be the same thing as 7/3. And then the ratio of areas is 49 over 9. Now, we have to use these ratios in order to set up proportions, which is what we're going to do in this next example down here. But just know, whenever you make your SPA chart should never have variables in it. So every time that we fill out a SPA chart, no matter what, we should always have numbers, never variables. So number 2, it says we have 2 similar triangles, so we're going to set up our SPA chart, and then we're supposed to find x. So if you look here, x is actually the side length. I don't know what that is. I'm looking for the side length, but what I was given was the area of both of my shapes. I was given area and area. So what I need to do is I actually need to set up my SPA chart with the area column first because that's what I was given. From here, we need to simplify this. So I would just use my calculator. 27 divided by 12 is going to get me 9 over 4. So the area ratio is 9 over 4. So now I have to actually figure out what my side/perimeter ratio is based off of the area ratio. And because your area ratio is always your side ratio squared, we're going to have to go backwards to get our S&P column, which is going to be 3 over 2. So now that I know what my ratio is supposed to be for my sides, I am going to take the 2 sides that I was given, my x and my 2, and the ratio I'm supposed to be using. So this is going to be x over 2, and that's going to equal 3 over 2. And then we will cross multiply to figure out what x is. Now this one just happens to be 3. They don't always end up being the same like that. It's just how this one happened, okay? All right. Number 3, it says the triangles are similar. Find the area and the perimeter of the triangle on the right. So I am looking for area and perimeter for this triangle on the right. So what I'm going to do is set up my SPA chart, and I'm going to put in whatever I was given. I was given my side lengths, so I have to put that in my S&P ratio. And then I need to fill out my area ratio by squaring both the numerator and the denominator. Okay, so now I have these two ratios. I've got my S and my P ratio, and then I've got my A ratio. So first thing I need to do is find my area. I'm going to call that X, and then I'm going to call my perimeter Y. So I need to, when I am looking for my area, I need to use my area ratio that I have in my SPA chart. So we have 50 over X will equal 25 over 9. We will cross multiply, so we're going to do 9 times 50 divided by 25, and we get that our area is going to be 18 meters squared. Now, I'm going to do the same thing with my perimeter, but because I'm looking for perimeter, I need the perimeter ratio. So now I've got 30 over Y equals 5 over 3. And we get that, something's not right. I multiplied wrong. 30 times 3 divided by 5. There we go. And we get that Y is going to be 18 meters again. I don't know why they ended up being the same, but they were on this one. Okay. All right, moving on. The base and the height of a rectangle are doubled in length. If the area of the original rectangle is 48 meters squared, what is the area of the new rectangle? So this one did not tell me that my figures were similar, but anytime that you change dimensions equally, so because I'm changing the base and the height by a factor of 2, I know that my shapes will be similar, okay? So because my base and my height or my sides have doubled in length, I'm going to set up my SPA chart by saying that my original rectangle had just a side ratio of 1, and then it's doubling, so that's going to be a 1 to 2 ratio. So that means that my area will be a 1 to 4 ratio, okay? This is my old image, and then this is my new image. My new image is doubled, it's bigger, okay? So it says, if the area of the original rectangle is 48, what is the area of the new rectangle? I'm looking for the area, so I need my area ratio. So this is 1 over 4, and that's going to equal, and then I need the area of the original rectangle is 48, so that's going to go on top where my old or my original shape information is. I will do 48 times 4, and I get that the area of my new image is 192 meters squared. Okay. All right, number 5. It says the side lengths of a triangle are reduced to 1/3 of their original length. Okay, so because everything's changing equally, we're going to set up our SPA chart. Now, they gave us a 1 to 3, like it's being reduced by 1/3. You can just use that. You just have to know that your old is now on bottom and your new is now on top. It doesn't matter where you put them. You just have to know what goes where. Because my image is shrinking, I want my old image to be the bigger one and my new image to be the smaller one. So then when I go to find my area ratio, that's going to be a 1 to 9. All right, it says, if the area of the original triangle is 54, what is the area of the new triangle? So because I'm working with area, I need my area ratio. Now it says if the area of the original, so original is supposed to be on bottom. So I'm going to put 54 on bottom. So 54 times 1 divided by 9 is 6. So the area of the new triangle is 6 meters squared. And then it says if the perimeter of the original triangle was 36, what is the perimeter of the new triangle? Because it's looking for perimeter, I need my perimeter ratio. So we have 1 over 3 equals x over 36. Remember, original goes on bottom in this example. So we will multiply 36 times 1 divided by 3, and that gets me that my perimeter is 12 meters. And then lastly, it says if the dimensions of a rectangle are doubled in length, how are perimeter and area affected? So if you are doubling in length, that means that you are going from a 1 to 2 ratio, and so your area will become a 1 to 4 ratio. So it says how are perimeter and area affected? Well, your perimeter will also double, because whatever happens to your side lengths or your dimensions, your perimeter does the same thing. And then your area would be 4 times as large. And we just get that information from the SPA chart itself, okay? So SPA chart's not super difficult to use. However, comma, it does require you to remember a couple of things, okay? The biggest thing is that you can never have variables in your SPA chart. So notice that in every one of our SPA charts that we created here, there, none of these had variables in them. Okay, so that's the first thing that's important. No variables in your SPA chart. And then the second thing that's important is you always need to reduce information within your SPA chart. We really only had to do that once right here in example number 2, when we had to reduce our area before we were able to find our S&P ratio. So whenever you put something into the SPA chart to start, you need to make sure that it is only numbers and that they are reduced. Okay. If you can do that, then the rest of the stuff is pretty easy to use. But again, we only use SPA charts with similar figures. So just be very careful as you go through your problems and just make sure that they are truly similar figures. But that's all I have for you. If you have any other questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next one. Bye.